In this video, we return to the ServiceNow database and continue building our understanding of how it's built and how it works. We'll focus on three things: table extensions, which we can use to help build hierarchical database structures. And then we'll cover some tips and tricks that you can use to become as productive as possible when working with the database. And finally, we're going to create our very own custom database table. It's going to be awesome. Welcome to our newly updated ServiceNow Fundamentals series. Jeff here from ServiceNow Simple, where we help you understand the ins and outs of ServiceNow with a focus on keeping things as simple as possible. Some of the keywords to watch for in this video include table extension, hierarchical database, base table, parent table, and child table, .list, .form, and .filter. And have I thanked you lately for being part of the channel and watching the videos? If I haven't, I do now. Thanks for being part of the channel. And subscribe if you haven't already. For now, let's jump into it. So we're talking about the ServiceNow platform, specifically the database. And we're picking up where we left off in our last video, which if you haven't watched it, you should, because it's awesome. There we learned that ServiceNow uses a relational database, and that we can use reference fields to create relationships between records in different tables. And those relationships are super powerful in that they make storage efficient and they eliminate the need to store the same data in multiple places. And now we're going back to look at another database capability that ServiceNow provides to further enhance the efficiency of the database. And that's the ability for one table to extend another table, creating a parent-child type relationship. Let's look at an example. Suppose we need to create a set of tables in our database to store all of our IT hardware components. So we create a table named hardware. Now we need to decide what information we want to store about our hardware so we can build out our list of fields. We know right off that we want to store a name for each piece of hardware, and we'll also store the serial number. Nice. We'll need to store a record for each of our printers, and we'd like to store the paper size and whether or not the printer supports color printing. Perfect. And for our computers, we need to keep track of the amount of disk space that they came with and memory. Oh, and for our computers that are servers, we need to record the host name and the cluster ID. And we should probably store if they're Unix or Windows servers. Cool. That's enough for now. So our hardware table is now set up with fields for storing hardware, including printers, desktop and laptop computers, and servers. And I like our table design, but I don't love it, and here's why. I can see that when I need to add a record for a printer, I'm going to have these computer-specific fields for things like disk space and RAM that don't apply to printers. And these server-specific fields for host name and cluster ID and server type. I don't need those for printers either. I guess I'll have to leave those fields empty for our printer records. And when we create new records for our servers, we don't need these printer-specific fields for things like paper size and color printing. Those don't describe servers. And when we add records for laptops and PCs, we don't need the printer fields or the server fields. Ugh. No worries, this is where the power of table extension helps out. Here's how we could use table extensions to solve our problem and build a better design. Let's try this again. We'll start with our hardware table. We'll build it only with the fields that apply to all types of hardware. Let's say name and serial number. I think all hardware should have those attributes. Now let's create another table named printer that extends our hardware table. So our hardware table becomes the parent and the printer table becomes the child. A printer is just a more specific type of hardware. When we build with an extension like this, the child table automatically inherits all of the attributes of the parent table. So our printer table inherits the name and the serial number fields from its parent, the hardware table. And now we can add the more specific printer fields to our printer table. Let's add those fields for paper size and color printing here. Sweet. Now let's add another table for storing our computers. And it too will be created as an extension of hardware. Computers are just more specific types of hardware. It inherits the two fields from the parent table again, and we'll add our computer-specific fields for disk space, memory, here. Very good. And finally, we'll create a table for our servers, but this time we'll have it extend our computer table, because servers are just more specific types of computers. Now it will inherit all of the attributes from the computer table and all of the attributes of the hardware table. We'll add our server-specific fields for hostname and cluster ID here. Excellent. We can continue by adding a Unix server table and a Windows server table that extend our server table. Now, if we walk down our hierarchy of tables, this should demonstrate the power of table extensions. First, everything that extends hardware should in fact be hardware, and they are. Printers and computers, servers and Unix servers and Linux servers are all just specific types of hardware. Further, everything that extends computer should be computers, and they are. Servers, Unix servers, and Windows servers are all just specific types of computers. And everything that extends server should be servers, and they are. Windows servers and Unix servers are just more specific types of servers. Each table stores only the fields that make sense at that level, so there's no need for dealing with fields that don't apply or need to be left empty. It's the beauty of table extensions. They allow us to build a hierarchy of database tables that get more specific as we traverse down the hierarchy, and they add attributes as needed in the appropriate places. Now let's assume it's time to load our data. Let's say we need to add 2 printers. We insert the records into the printer table. And we have all of the fields we need and no more. And upon insert, we'll see 2 records in the printer table and 2 records in the hardware table. If we then insert 3 records into the computer table, let's say for 3 laptops, we'll have 3 records in the computer table, and now we'll have 5 records in the hardware table. Let's add 2 server records. We'll have 2 records in the server table, and 5 records in the computer table, 7 records in the hardware table. And if we add a record to the Unix server table, we end up with 1 Unix server record, 3 server records, 6 computer records, and 8 hardware records. And this is awesome because we can see the total number of hardware components we've got stored at each of the various levels of our hierarchy. It's all neat and tidy, super efficient. And that's how extending tables in ServiceNow works. Now let's jump into the UI and see how this looks in a real implemented solution. And fortunately, the data model we just walked through works as a perfect example. I'll start by opening the Application Navigator and navigating down to the System Definition Applications Tables module. This opens a list view of all the records stored in the table, which is one of those ServiceNow data dictionary tables that stores a record for every table that exists in the database. I want to look at one of the tables that we had at the bottom of our data model hierarchy. Let's say the Unix server table. I'll filter the list for tables that have a label starting with Unix server. There's the dictionary table entry for the Unix server table. Notice its name is CMDB CI Unix server. Notice here that the extends attribute of the table shows that it extends the server table, just like our data model diagram does. I'll go ahead and click the linked value in the first column to open the dictionary record for this table. Here you can see the table's label and name fields and the extends field. This is where it defines the table as an extension of the server table. So when this table was created, it was created as an extension of the server table, which means it inherits all of the attributes of the server table and all of the other parent tables up the hierarchy. Let's scroll down below the related list section to the related links section. Let's open the schema map for this table. And here you have it. Notice that the Show Extended Tables and Show Extending Tables checkboxes are selected here. What we can see is that the Unix server table extends the server table, which extends the computer table, which extends the hardware table. And in this case, even the hardware table has a parent and grandparent that provide some very basic attributes that serve the needs of the ServiceNow platform. Notice also that in the ServiceNow database, they've gone ahead and extended the Unix server table with children even more specific for Unix servers, Solaris servers, HPUX servers, and AIX servers. I love these schema maps because they can tell us all sorts of things about the structure of the database. Remember, you can add the field level reference relationships by selecting the Show Referenced Fields and Show Referencing Field checkboxes here. You can also see which fields get added to the table at the different levels of the extension hierarchy. The server table, for example, adds these fields at the server level. And it inherits these fields from the computer table. And the fields it inherits from the hardware table are these. And on as far as the hierarchy extends. And if you're interested in learning what other tables extend the server table, for example, we can right-click on it and choose the Focus on this Table item. Now we're viewing the schema map for the server table. And look at all of its children. And each child inherits the attributes of the server table and all of its ancestors. Another thing you can do from these schema maps is quickly jump to a list view of the data that's stored in the table, or open the data dictionary entry of the table. It's like a one-stop shop for database goodness. And hopefully you can begin to imagine how powerful these table extension capabilities can be in designing a well-organized and efficient database. It supports the data storage needs of a whole wide range of applications. One more quick thing on the topic of table extensions. Just some terminology you should be aware of. A table at the top of a hierarchy that has no parents but has children is called a base table. In our example data model, the hardware table would have been our base table, although that's not really true in ServiceNow because it has parents, but you get the point. Parent table is the table being extended, and the child table is the table that's doing the extending. And just to be aware, all of the tables that come with the ServiceNow database out of box are referred to as core tables. And any tables you create on your own are called custom tables. Now let's turn our attention to some nice little tricks that we can use to improve our productivity when we're working with the database from within the ServiceNow user interface. And I'll start by navigating to the System Definition Applications Tables module again. If you remember, this is that table that displays a list view of all the records that are stored in the table. It's the dictionary table that stores a record for every table in the database. Let's say we need to run a query on a table and we want to see all of its data, but we don't know which application or module we need to use to pull up that list. The UI provides a super easy method of opening the list view for any table, assuming that you have the appropriate permissions. What we do is we enter the name of the table followed by .list into the Application Navigator's filter field. Let's try it. I'll scroll down here a bit and find a table that might be interesting. How about this asset table named ALM_asset? Let's say we want to see all the records in the asset table. I'll click on the All menu to open the Application Navigator, and in the filter, I'll enter ALM_asset.list. Hit enter. And there you have it. The list view of all the records in the asset table. Pretty cool. Once you do this a few times, you'll begin to remember the names of some of your favorite database tables. I know, for example, that the user table, which stores a record for all of the users, is named sys_user. So I'll enter sys_user.list and hit enter. Now I'm viewing a list of all the records in the user table. Pretty cool. Now let's say I want to get back to that dictionary table of tables. And I happen to remember it's named sys_db_object. So sys_db_object.list. And I'm back to where we started with our list of tables. So we can view the data that's stored in any table by using the App Navigator's filter field and just entering the table name .list. Another option here is to enter the .list command, but with list in uppercase. And what that does is the same thing, but it'll open the list in a new browser tab, which allows you to quickly get back to where you were by switching tabs. That's pretty cool. We can do something similar to access the form view for any table. In this case, let's say we want to enter a new record into the user table. I can enter table name.form in the nav filter. So sys_user.form, and now we've opened the form view for the user table and it's in create mode. We're ready to fill out the form and create a new record. And again, enter form in uppercase to open it in a new browser tab. Let me show you one more, and this is just a twist on the .list command. Let's say we want to open a list view of a table that we know stores a lot of records. We're only interested in seeing a subset of those records. What we can do is enter table name.filter. I'll enter sys_user.filter. What this does is open the list view for the table, but it doesn't execute the initial query, which might take a long time for a really large table. And now what we can do is we can use the tools available on the list view to create a filter. Narrow down the list and only pull the records we're interested in. I'll say users where the department is sales. There's my list. So this is great for opening very large tables and getting to a manageable subset of the records without the expense of that initial query that comes with .list. The key to using these shortcut commands is knowing the name of the tables you're interested in. So start memorizing table names if you want to. Otherwise, if you don't happen to know the name of the table, just remember the sys_db_object table. Open the list view for that table, that's that table of tables. Then you can look through and filter, find the table you're interested in, and get the name that way. Okay, now for something even more fun, if you can imagine that. Let's put on our ServiceNow developer hats and create a brand new custom database table. Let's say we're creating a custom application in ServiceNow to manage an upcoming company potluck, and we need a database table to store the food that's going to be brought. We need to record the name of the dish, the number of the people it'll serve, whether or not a power receptacle is required to keep it warm, and the person who will be bringing the dish. We put some thought into the design of our table and we come up with this. We'll name our table Potluck Item, and we'll include 4 fields as follows. First, we'll create a field labeled Item Name. We'll use a string data type to allow for storing general, like free-form text. Next, we'll define a field labeled Servings to store the number of people that the item can serve, and we'll use an integer data type for that. To track the need for the power receptacle, we'll create a field labeled Power Required. We'll set that as a true-false field. And then finally, we'll add a field labeled Contributor to record who's bringing it. And for this field, we'll build a reference to the user table because all of our employees already have user records populated in the database. Okay, let's do this. As with most things in ServiceNow, there are a number of ways we can go about creating a database table. We could, for example, use one of the low-code, no-code tools like App Engine Studio. It walks through the process of creating custom applications and database tables using a wizard-like paradigm. It hides some of the complexity, limits some of the options, provides a non-technical user the ability to solve some of their own business problems. But I'd rather demonstrate the details, so we'll go the more traditional route using the dictionary tables and good old list views and form views. Start by navigating back to the System Definition application and selecting the Tables module again. This is that list view for the table, where everything in the record represents a table in the database. Well, we want to create a new table in the database, so I'll click the New button here to add a record. That opens the form view for the table. in create mode. It's ready for us to populate, create a new record. We'll label our table potluck item. Now notice that when I tab off of the label field, the system auto-populates the name field, replacing any spaces with underscores and removing any special characters and the like. Also notice that as a rule, all custom database tables in ServiceNow begin with a U underscore. We can change the other part of the table name here. I normally don't. We'll leave the name as our table is. U underscore potluck underscore item. That's fine. The extends table field right here is where we would set the parent table if we were using a table extension. We don't need to extend an existing table here, so we'll just leave that blank. And then the remainder of the fields don't really apply to what we're doing right now, so I'm going to leave those alone. Notice that down here in the related list section of the form, we have a tab for displaying the fields or the columns that exist on the table. Right now there are none because we haven't created any yet, but we're going to use this area to add our fields in a second. But before we do that, I want to save what we've done so far and show you something interesting. I'll access the Additional Actions menu and select the Save item. When I do that, the record of our new table gets inserted into the table, and notice that when the page refreshes, we suddenly have a set of 6 fields included on our table. Here's why. ServiceNow's decided that every table in the database will include a minimal set of 6 fields for identification and auditing purposes. As I mentioned previously, every table in the database has a field named SysID. It serves as the unique identifier and primary key of any record. In addition, every table automatically gets fields for storing when the records are created and updated and by whom. So every time we create a custom table, these 6 fields automatically get created. Now let's begin adding our custom fields. I'll click the New button on the columns related list here to add a new column or field to our table. I'll add the item name field using a string data type. Notice that the field names also get populated, including the U underscore prefix. I'll set the max length attribute to 100 characters and leave these remaining attributes as they are. Then I'll submit the form. Now we can see our item name field has been added here. Next, I'll add the servings field using the integer data type. And submit. And the power required field as a true-false data type. Awesome. Lastly, I'll add the contributor field using the reference data type. When you're creating a field with a reference data type, you have to take the additional step of defining which other table the field will refer to. I'll do that by clicking on the Reference Specification tab here, and in the reference field, I'll specify the user table, sys underscore user. Our contributor field will reference a record from the user table. And that's it. Submit, and our table is now created with all of our fields. Okay, time to take it for a test drive. We created our table with the name U underscore potluck underscore item. That means we can enter U underscore potluck underscore item dot list in the filter navigator to open the default list view. And here it is. But there are no records to display. Let's add one. I'll click the New button to open our new table's default form in create mode. Notice here how the fields are displayed. The label for each field displays the label value we set for the field in the database. and the element that's used to display and collect the data are determined by the field's data type. Standard input boxes are used for string and integer fields. Checkboxes are used for true-false fields, and this lookup element is used for reference fields. Let's go ahead and add a record. Abraham Lincoln will be bringing a Caesar salad that serves 20, and it does not require any sort of power. Let's do one more. A baked ham that serves 15 will be provided by Fred Luddy, and it does require power for the roaster to keep it warm. How awesome is this? Our new table is working perfectly. And just for fun, let's have a quick look at our table's schema map. I'll open the Column Options menu, choose the Configure Table item. And here's the structural view of our table. Scroll down below the Related Lists section to the Related Links section. Click the Show Schema Map link. Here's our table. Here are its fields. Our table didn't extend another table, so no relationships display currently, but we do have a reference field. I'll select the Show Referenced Fields checkbox. Now we can see that our table includes a field referencing the user table. Beautiful. From here, I can right-click on our table and select Go to List to return to our data. And hey, I must say, starting to get the hang of this ServiceNow database stuff. And we'll revisit much of this in upcoming videos, especially when we dive deeper into the world of ServiceNow development. But for now, you've built a really strong foundation. Congratulations. Thanks for watching this one, and I'll see you in the next one.